Ice. Landscapes littered with hundreds of active volcanoes.
So now, the zone where life could possibly exist has expanded out from Earth to the outer reaches of the solar system.
And places where jets erupt hundreds of miles into space.
We could hold in our hands evidence for extraterrestrial life.
And the same epic forces that gave birth to our solar system are at work throughout the universe. Tens of billions of planets are estimated to be orbiting other stars in our own galaxy alone. Could there be an Earth-like planet among them?
We will find habitable worlds for sure, if not this week or next month or next year, sooner or later.
Finding life beyond Earth. Up now on Nova. The possibility of life beyond Earth is a tantalizing idea, long prompting our species to wonder if there are other worlds where life exists. Now, as space technology advances, the chances of finding it are greater than ever.
I would love to find life beyond Earth. I'd like to think that we could do that. And I'd like to think that we could do that in the next several years.
The search focuses on three key ingredients. The first one is life's basic chemical building blocks, made from simple elements found in the cloud of gas and dust that gave birth to all the planets and moons. These chemicals were possibly delivered throughout the solar system billions of years ago by comets and asteroids. They are compounds called organics, containing carbon, oxygen, hydrogen, and nitrogen. Next, life needs a liquid, like water, that allows these compounds to mix and interact. And finally, an energy source, like the sun, to power the chemical reactions that make life possible. Scientists were once convinced that all three ingredients could only be found, if at all, on planets that are at just the right distance from the sun. Too close, and it's too hot. Any further away than Mars, and it's too cold. But now, missions to the outer solar system are calling this assumption into question. This is Jupiter, as seen by the space probe Voyager 1, launched decades ago to explore the outer solar system. 500 million miles from the sun, it seems unlikely that life could exist out here in such extreme cold. Voyager approaches Io, one of Jupiter's more than 60 moons, orbiting in the shadow of the gas giant. Io should be a frozen, icy, barren world. But Voyager spots something completely unexpected. these actual images of Io's surface reveal hundreds of giant, active volcanoes. Later probes expose vast lakes of molten lava. On Earth, volcanic activity is driven by heat in the interior. But Io is so small that it should have cooled down billions of years ago. There must be another source of energy inside the moon.
The discovery of active volcanism on Io was one of the greatest discoveries of planetary science.
By observing Earth's volcanoes and studying the huge amount of data gathered from Io, Ashley Davies pictures what walking on Io's surface would be like.
Walking across the surface of Io, it's a very, very hostile environment. It's either very, very cold or it's very, very hot where there's volcanic activity taking place. And of course, there's no atmosphere. There'd be a bounce in your step because the gravity of Io is about the same on the moon, 1/6 of the Earth. You could feel the crunch underfoot as you head from one volcano to another across these vast plains. Well, here we are in the middle of a vast lava flow field. It's dark, it's quite hot. This is comprised of lava flows that have erupted from one of Io's many volcanoes, like that one over there.
The probe New Horizons flies past Io. It takes this photograph of an enormous eruption from a volcano called Tvashtar. A vast plume of sulfur shoots 200 miles into space. These actual images reveal the plume as it spreads out and rains back to the surface.
On Io, we see these large volcanic eruptions. The gases that are coming out of the lava blast this material high into space, into the vacuum of space. It's very, very spectacular.
What could be generating so much energy in a moon that should be frozen solid? And where is the power coming from? The key to understanding Io's volcanic activity is its parent planet, Jupiter. Io orbits Jupiter in a slight ellipse rather than a circle. With every orbit, Io experiences gravitational pushes and pulls from Jupiter and other moons. When Io is closest to the giant planet, it is stretched by more than 330 feet. Over billions of years, this has created an immense amount of friction deep inside the moon.
This continual flexing of the satellite, it's like bending a piece of metal. It heats up. And this is the ultimate source of Io's volcanic energy and its volcanic heart.
The powerful tidal force generated by the massive gravitational pull of Jupiter creates an alternate source of energy far from the warmth of the sun. A source of energy that could, in principle, support life.
What's so important about Io is that it moves our perceptions away from a habitable zone around the sun where energy is just derived completely from the sun. So now the zone where life could possibly exist has expanded out from Earth to the outer reaches of the solar system.
But the chances of life existing on Io itself are slim. Even though it has an energy source and could have the right chemical building blocks, possibly delivered by comets and asteroids billions of years ago, scientists have not yet detected the third key ingredient, a liquid like water. But Io is not the only moon circling Jupiter. NASA's unmanned space probe Galileo flies by the next moon out, Europa.
It passed by Europa 12 times, and only 12 times. Virtually everything we know about Europa is from those 12 passes, and each and every one of them has excited us beyond belief.
Slightly smaller than our own moon, Europa is covered with ice. Data collected by Galileo shows that the surface is minus 260 degrees Fahrenheit, surely hostile to life. But as the probe gets closer, it takes these images. A mysterious network of dark cracks is etched into Europa's icy surface.
We see places where very clearly the ice has cracked and two sides have spread apart. Material has come up and frozen in the middle to fill the gap.
In addition to the dark cracks, the probe also reveals vast, jagged areas of ice that appear to have melted, broken apart, and frozen back together again.
There's something very dramatic happening to destroy the existing surface there.
To an expert eye, it's a familiar pattern. Sea ice found on Earth looks very similar. Then, Galileo takes readings of Europa's magnetic field. These indicate an electric current flowing inside, consistent with an ocean of salty liquid water.
It's very hard to get that pattern without having an ocean underneath the ice.
The magnetic field data suggests that miles down, beneath Europa's icy surface, there is an ocean that could be 60 miles deep. This small moon could have twice as much liquid water as in all the oceans on Earth. Something must be melting the moon from deep inside. And again, the key is Jupiter. The same gravitational forces that flex Io's rocky interior, turning it into an ocean of magma, are melting Europa's ice to produce its hidden ocean of liquid water, and creating the cracks on the moon's icy surface.
The ice is creaking and groaning around. That generates a huge amount of friction and a huge amount of heat.
But the question is, could anything live in this cold liquid ocean, concealed beneath miles of ice, where there is no energy from the sun? To find out, biologist Tim Shank explores the oceans here on Earth that most resemble Europa's icy depths. 200 miles from the North Pole, Tim sends robots to search for life. 12,000 feet beneath the Arctic ice sheets, where the sunlight never reaches.
Exploring the deep Arctic Ocean is not unlike exploring another planetary body in our solar system. You have to deal with immense pressures, temperatures, extremes where life might exist.
Here, volcanic activity is pushing apart the sea floor. Scientists believe that something similar may be at work under the ocean on Europa.
We believe it has a rocky core. That rocky core is under tidal forces and influences, and it's flexing also, just as the rest of the planet does. And that heat has got to go somewhere.
On the restless floor of the Arctic Ocean, Tim's robots discover evidence of an extremely hostile environment. Volcanic vents are spewing out water that is superheated to 700 degrees and laden with toxic chemicals like hydrogen sulfide. Tim believes that vents like this could also exist on Europa's ocean floors. And clustered around the vents in pitch darkness, Tim's team finds life.
We discovered new forms of life, microbes that cover miles of the seafloor there. There's life even in the coldest waters, in the deepest regions of our polar oceans that we didn't know about before.
Instead of using sunlight to trigger vital reactions, microbes like these use sulfur, hydrogen, and methane as chemical sources of energy. And the microbes form the basis of an extensive food chain. The discovery of life here raises the possibility of life on Europa.
It's clear to me that the basic components, the basic elements, the chemical elements that we need for life are on Europa. There's nothing that I can think of, no component that's missing from the European Ocean. I would be surprised if we didn't find life there, really.
With liquid water, an energy source, and the necessary chemical building blocks perhaps delivered by comets and asteroids, Europa opens up the possibility that life could exist in places never imagined.
And so the moons, as they go around the planets, are generating heat, melting water, creating under ice shell oceans, and producing a potential environment for life. That is a revolution in our thinking.
But getting a probe safely to the surface of Europa to test these theories is just one of the challenges in looking for life 500 million miles away.
You've got to build something that can get through what is surely kilometers of ice. That's hard to do on Earth. Then you've got to have something that can swim. You know, I mean, it's going to happen. I would love to live to see it, but it's a tough one.
Europa isn't the only intriguing place this far out in the solar system. Could similar conditions exist on other moons, orbiting other planets, even further away from the Sun? One mission launched to find out is the probe Cassini. It is heading for the ringed planet, Saturn, 1 billion miles from the Sun. Its mission: to explore Saturn, find out how its vast rings formed, and investigate some of its more than 60 moons.
Cassini's mission from the outset was to investigate everything we could about the Saturn system. It is a major exploratory expedition.
Cassini gives scientists their best view yet of this mysterious planetary system.
Cassini was outfitted with the most sophisticated suite of scientific instruments ever carried into the outer solar system. It has cameras, spectrometers. It is really the farthest robotic outpost that humanity has ever established around the Sun.
7 years after launch, Cassini finally enters orbit around Saturn. These images reveal the rings in unprecedented detail. They stretch out across hundreds of thousands of miles, yet in places they are just tens of feet thick. Using its instruments to analyze wavelengths of reflected light, Cassini confirms these majestic rings are made of billions of shining particles of almost pure water ice. They range in size from a grain of dust to the size of a mountain. After nearly 8 months collecting data of Saturn and its rings, Cassini makes its way to one of the closer moons. This tiny ball of ice, only 300 miles across, is Enceladus. These Cassini images reveal a glistening white surface, unlike any other of Saturn's moons. It is carved with crevasses, ridges, and cracks. And stretching out across the South Pole, Cassini photographs these strange large cracks seen here in blue. 4 parallel fissures scientists named the Tiger Stripes. They are 75 miles long and hundreds of feet deep. They look a lot like fault lines on Earth.
Enceladus was a major focus for the Cassini mission. It was clear that there had been something going on Enceladus in the past. The question was there anything going on Enceladus at present?
On another flyby, Cassini's thermal imaging sensors reveal something unexpected. At the South Pole, the Tiger Stripes should be colder than the rest of the moon, but they are radiating heat. Though still a frigid minus 120 degrees, the cracks are more than 200 degrees warmer than most of the moon. Then, as Cassini changes its orientation, it sees Enceladus, silhouetted by the sun, and vast jets of ice erupting into space. These actual images reveal the jets are blasting hundreds of miles out from the Tiger Stripes. Carolyn and her team are stunned.
Never did we expect that we were going to see something like a whole forest of jets shooting hundreds of kilometers into the sky above Enceladus. It was like nothing we'd ever seen before.
Could Enceladus also have an internal energy source, like Io and Europa? Scientists believe that when Enceladus orbits the massive Saturn, friction from gravitational forces causes it to heat up, melting ice in the moon's interior in the same way as on Europa. They believe the jets consist of liquid water, vaporizing and freezing as it meets the cold vacuum of space. They shoot upwards at 1,200 miles per hour.
Enceladus is being flexed as it's orbiting Saturn. That's like flexing a paperclip. It creates heat inside, and we think the heat maintains the liquid under the surface.
Excited by this discovery, the team programs Cassini to fly through the jets and collect particles. After several fly-throughs, Cassini's spectrometers detect in the jets some of the basic chemical building blocks of life.
That was tremendously exciting to find, because not only do we think there's liquid water there, not only is there an enormous amount of excess heat, but we also have organic materials. And that's the trifecta that we are looking for, the 3 main ingredients for a habitable zone.
But could this strange and alien world actually support life? Carolyn imagines what it would be like to hunt for the answer on the surface of Enceladus.
Walking on the surface of Enceladus, as you approach the tiger stripe fractures, you would first encounter a region that is continually blanketed in snow. The sky is inky black. Walking is like floating, has very little gravity. If we have the sun at our back, we wouldn't see anything. But if we put ourselves in the right geometry, looking in the direction of the sun, then suddenly we see something that I think would be the greatest spectacle this solar system has to offer. Giant ghostly fountains shooting skyward, fine, sparkly, icy crystals, most of which eventually fall back down and coat the surface in a blanket of snow. If we are correct that the jets of Enceladus derive from pockets of liquid water in which life might have gotten started, a scoopful of Enceladan snow just might contain the remains of microscopic living organisms.
Since Cassini's instruments cannot detect the signatures of life itself, there is no evidence yet of microscopic organisms in these jets. But the discovery makes Enceladus a prime candidate for future missions.
To me, it's like there's a sign on Enceladus that says, free samples, take one. We just got to fly through the plume and collect the stuff. We don't have to drill, we don't have to dig, we don't have to scurry around looking for it. It's being injected into space.
The discovery of a new energy source and the possible oceans of liquid water inside planetary moons point to potential new footholds for life in our solar system. Meanwhile, discoveries here on Earth are revealing that life can withstand an even wider variety of conditions than previously thought. Missions to extreme environments are showing that microbes can live in dry deserts and thrive in lakes full of poisonous arsenic. Bacteria survive in slimy colonies on cave walls dripping with sulfuric acid, living off noxious hydrogen sulfide gas. And microbes flourish in toxic rivers of corrosive industrial waste.
We now know it's possible for microorganisms to exist in these large acidic and even poisonous regions.
The more we look at the extreme habitats on Earth, the more we find life there. We're pushing back the limits of where life can live all the time through our own discovery.
From freezing glaciers to superheated hot springs, from high deserts blasted by ultraviolet radiation to deep mines miles underground and ocean trenches where sunlight never penetrates, scientists are discovering that life to adapt and thrive.
Life on Earth can exist in many extreme environments, and it can do many remarkable things. And we're learning more every day about how flexible and remarkable life on Earth really is.
So could environments on other worlds previously thought too harsh for life be worth a second look?
We really got to put ourselves out there in terms of thinking what the possibilities are.
When we first started looking for life on other worlds, we were looking for Earth-like conditions. Okay, well, we got to have water, got to have an energy source, got to have carbon. But to me, the number one question, the big question is there another type of life on another world somewhere in our solar system?
So Chris wants to know, If life could develop in new ways, perhaps even using different kinds of chemistry, then could even the most inhospitable places offer surprising new footholds for life? One such place is one of Saturn's moons, visited by the space probe Cassini, Saturn's largest moon, Titan. Cassini detects organic building blocks in the atmosphere, and the spacecraft's radar reveals something mysterious beneath clouds at the South Pole. It looks like a lake of water. Further flybys reveal it's just one of hundreds scattered across both the North and South Poles.
It was exciting and mysterious to see all these different lakes and to try to understand what's going on.
Titan is the first world other than the Earth known to have a liquid on its surface. But at minus 290 degrees, this liquid can't be water. Analysis of infrared light reflected off the lakes reveals that they are filled with super-chilled liquid methane and ethane. On Earth, these hydrocarbons are gases we use as fuel. Data now reveals that methane on Titan carves river valleys, forms clouds, and even falls as rain. Liquid methane acts a lot like water on Earth. But could it act the way water does, as an essential foundation for life, allowing organic molecules to dissolve, mix, and interact? It's a question astrobiologist Chris McKay is investigating.
Our general theory of life, based on one example on Earth, is that we need a liquid. Some people would argue that that liquid has to be water. Well, on Titan, we can ask the question, well, what about another liquid? Could some other liquid besides water do the trick?
For life to exist on Titan, Chris believes one fundamental process has to happen first. A process that, according to the most widely accepted theory, took place on early Earth and ultimately produced us. In this scenario, the raw ingredients of life, organic molecules, dissolved in water, and once in this liquid, they came together and reacted to form bigger, more complex molecules that would eventually, somehow, become living things. For life to have a chance on Titan, the building blocks would have to dissolve in liquid methane. Chris is now trying to find out if this is possible. He first has to replicate the organic building blocks that Cassini's instruments detected high in Titan's atmosphere. Simulating an energy source, Chris fires an electric spark that hits gases inside the test tube that are known to exist on Titan. This creates organic molecules similar to those in Titan's atmosphere. The brown residue at the bottom of the tube.
And we trigger the same reactions in the flask, and as a result, we produce the same kind of solid organic material in the flask that is being produced in Titan's atmosphere.
Then, Chris recreates Titan's remarkable lakes. He fills the test tube with methane gas, and then cools it below minus 290 degrees using liquid nitrogen. Now the methane liquefies, just as it does on Titan's frigid surface.
So in the flask, we'll have a miniature little lake, a little puddle of liquid methane swirling around in that organic material. Will anything dissolve in that organic material? That's the question. And will that, over time, build up organic complexity? Could it be the start of what could be another type of life?
No one knows exactly how life gets started, But the question Chris is interested in is, can organic compounds dissolve in liquids like methane? If so, it would suggest that even at extremely cold temperatures, the chemistry needed for life could be possible in liquids other than water.
We know that there's conditions there that maintain liquid, there's energy sources, there's organic material, there's nutrients, there's an environment that may be suitable for life. But if there's life there, it's going to be completely different than anything we have on Earth.
Chris's experiment is one step toward understanding whether there could be life on Titan.
To me, the most exciting possibility is that there is life on Titan, because then that would show not just that life started twice, but it started twice in very different conditions. It would show us that life is a natural process that's going to pop up on many different worlds, many different planets around many different stars.
Titan, Enceladus, Europa, and Io show that even within our solar system there are places where some scientists believe life could potentially gain a foothold.
Might be extreme life, might be life that we've never seen before in terms of its structure and its composition. But we're now realizing that those environments could harbor life.
The three vital factors, energy, liquids, and chemical building blocks, are more widespread than has ever been realized. And if it's possible here, then could the right conditions also exist beyond the boundaries of our own solar system?
By understanding our own solar system, I believe we'll then be well on our way to understanding the conditions that could occur around other stars and throughout our galaxy. It really changes our view of this universe.
Is there somewhere out there a star like our sun, orbited by habitable planets that are teeming with life? There are billions of stars just like our sun within our galaxy, and the odds suggest that tens of billions of planets are orbiting around them. If there is life out there, can we find it? Astronomer Mario Livio is at the forefront of the search. He's using the Hubble Space Telescope to look deep into space to where new stars like our sun are bursting into life. This is the Orion Nebula, as seen by Hubble. Here, 1,500 light-years beyond our solar system, new stars are being born inside a vast cloud of dust and gas.
So when we look at the nebula now, it's almost like looking into a cave. We see this hollow part where gas and dust has been blown away, and inside where these stars are being born.
And right inside, among all the shining stars, is what looks like a small dark smudge. In fact, it is a young sun, surrounded by a dense disk of dust and gas, more than 50 billion miles across. This smudge represents the dawn of a new solar system.
In this case, we see the disk edge on, and therefore the disk completely obscures the light from the star, and this is why you don't see the star.
Other images show similar disks tilted to reveal the star at the center. These spinning clouds of matter may one day form planets and moons, as particles of dust, ice, and gas collide and clump together. This is the same process that is thought to have created the planets of our solar system. Hubble has revealed that swirling disks like this are extremely common.
The fact that we see these very often tells us that these raw materials from which planets form are very, very common. And so that planetary systems form probably around most stars.
But do these young solar systems produce Earth-like planets containing the right ingredients needed to sustain life? Astronomer Josh Eisner wants to find out. He has come to Mauna Kea, Hawaii, to look at the clouds of gas and dust in more detail.
We'd really like to understand, are there building blocks of life there? Are things that we associate, at least with life on our planet, available for planet formation around other stars?
Analyzing gas and tiny bits of dust from hundreds of light years away is no simple feat. It requires instruments of great sensitivity and precision, the Keck telescopes. 14,000 feet up on the summit of a dormant volcano, these twin telescopes are among the most powerful on Earth. Josh uses both of them together. And with a spectroscope to analyze infrared light emitted from inside the early solar systems, he can tell what they are made of.
We're actually trying to map a detailed picture of the dust and what that hot gas is made of. Is there water vapor there that might get incorporated into an atmosphere one day or into an ocean one day?
His findings are encouraging. In some of the distant solar systems, Josh is detecting evidence of carbon, oxygen, and hydrogen, 3 key elements needed to produce the chemical building blocks on which life depends. Even more intriguing is that in some disks, those ingredients also appear to be at the right distance from their stars to form planets with Earth-like qualities. So much for theory. The question is, do such planets actually exist? Jeff Marcy is one astronomer trying to directly answer that question. He's a planet hunter, scanning the heavens for signs of planets that may have already formed around other stars, thousands of light years away from our solar system.
It is actually quite a challenge to find planets around other stars, and the reason is very simple. Planets don't shine. Planets are essentially dark.
By using advanced telescopes, dedicated planet hunters like Jeff have found ways to overcome this challenge.
If you watch a star, it ought to have the same brightness all the time, 24/7. But if there's a planet orbiting that star, when the planet crosses in front of the star, the planet will block a little of the starlight, and you'll see the star dim a tiny amount every time the planet crosses in front, over and over in a repeated way. And marvelously, you can learn the size of the planet, because the bigger the planet is, the more light from the star it blocks. And so we learn an enormous amount of information about these planets just by watching stars dim.
Not surprisingly, most of the planets astronomers have found this way are giant ones that block a lot of starlight. By also observing the gravitational pull they have on their stars, Jeff calculates that most of these giant planets are made of gas and are unlikely to be habitable. But the Holy Grail is to find far smaller, rocky worlds, like Earth, where the conditions for life could exist.
The challenge of finding Earth-sized planets is enormous. When an Earth crosses in front of a star, it blocks only 1/100th of 1% of the light from the star.
The Kepler Space Telescope is designed to detect this subtle dimming. Its mission, to focus on one tiny spot of space and scrutinize 150,000 stars for signs of planets the size of Earth. Sensitive enough to detect minute dips in a star's light, Kepler is already producing mountains of data, and thousands of new planet candidates are being discovered.
Kepler has now already discovered a few planets that have a diameter and a mass that indicates clearly the planet is rocky. And so we now have, for the first time in human history, definite planets out there among the stars that remind us of home.
These first rocky planets are too close to their stars to sustain life. But the sheer number of smaller planets being found is transforming our view of solar systems beyond our own.
We've learned that nature makes some large planets the size of Jupiter and Saturn, but nature makes even more of the smaller planets the size of Neptune, and even more of the planets the size of the Earth. The number of planets is sort of like the rocks and pebbles you see on a beach. There are a few big boulders. There are many more rocks, and there are an uncountable number of grains of sand that represent the Earth-sized planets we see in the cosmos.
Jeff believes it's only a matter of time before we find a habitable planet.
I suspect that this scene we see here is one that's reproduced billions of times over among the Earth-like planets, the habitable planets in our Milky Way galaxy.
But even if we find a world just the right size and in just the right place with oceans of liquid water, could we detect life from a distance of trillions of miles? The James Webb Space Telescope may be able to do just that. Due to go into orbit later this decade, this new telescope is 3 times more powerful than Hubble. It will be able to analyze starlight passing through the atmospheres of the closest Earth-like worlds, looking for the telltale signs of life itself.
I think the chances are very good that if you find a planet with oxygen, methane, carbon dioxide, nitrogen, like our own Earth, there's probably plant life on that planet that is producing the oxygen.
As telescopes see farther and spacecraft voyage closer to distant worlds, new discoveries are transforming what we thought we knew about our solar system and our galaxy.
I am constantly awestruck by the data that's coming in our current fleet of missions. Science fiction didn't tell us in any way, shape, or form what we're finding out now.
Years from now, people are going to look back on this as being the golden age of exploration of the solar system. You can only go someplace for the first time once, right? And we're doing that now.
Scientists are finding organic molecules, the raw ingredients that life needs to take hold in our solar system and beyond.
I think we'd be naive to think that this chemistry and life here on Earth is the only place that's happening in the universe. I mean, the fact is we've got billions of galaxies, trillions of star-forming environments that probably have the same chemistry going on.
The right conditions that make a world habitable could be more widespread than ever imagined.
All of this leads us to think that life should be an easy start on another world.
And the same forces of nature that forged life here could be playing out elsewhere in our galaxy.
A lovely exercise for everyone to do is to look up into the night sky, look at the twinkling lights, and realize that those stars, by and large, all have planets. And that's just our galaxy. there are hundreds of billions of galaxies out there, like our Milky Way, and so the number of planets in our universe is a truly uncountable number.
So the race is now on to see if life actually exists beyond Earth. Will life first be discovered on a moon such as Enceladus? Will it be found by an advanced telescope, or will it be found at all? Whatever the answer, many believe this is a turning point in history when we at last have the technology and the know-how to find out if there is life beyond Earth. Ice. Landscapes littered with hundreds of active volcanoes.
So now, the zone where life could possibly exist has expanded out from Earth to the outer reaches of the solar system.
And places where jets erupt hundreds of miles into space.
We could hold in our hands evidence for extraterrestrial life.
And the same epic forces that gave birth to our solar system are at work throughout the universe. Tens of billions of planets are estimated to be orbiting other stars in our own galaxy alone. Could there be an Earth-like planet among them?
We will find habitable worlds for sure, if not this week or next month or next year, sooner or later.
Finding life beyond Earth. Up now on Nova. The possibility of life beyond Earth is a tantalizing idea, long prompting our species to wonder if there are other worlds where life exists. Now, as space technology advances, the chances of finding it are greater than ever.
I would love to find life beyond Earth. I'd like to think that we could do that. And I'd like to think that we could do that in the next several years.
The search focuses on three key ingredients. The first one is life's basic chemical building blocks, made from simple elements found in the cloud of gas and dust that gave birth to all the planets and moons. These chemicals were possibly delivered throughout the solar system billions of years ago by comets and asteroids. They are compounds called organics, containing carbon, oxygen, hydrogen, and nitrogen. Next, life needs a liquid, like water, that allows these compounds to mix and interact.
Look, it's quite hot. This is comprised of lava flows that have erupted from one of Io's many volcanoes, like that one over there.
The probe New Horizons flies past Io. It takes this photograph of an enormous eruption from a volcano called Tvashtar. A vast plume of sulfur shoots 200 miles into space. These actual images reveal the plume as it spreads out and rains back to the surface.
On Io, we see these large volcanic eruptions. The gases that are coming out of the lava blast this material high into space, into the vacuum of space. It's very, very spectacular.
What could be generating so much energy in a moon that should be frozen solid? And where is the power coming from? The key to understanding Io's volcanic activity is its parent planet, Jupiter. Io orbits Jupiter in a slight ellipse rather than a circle. With every orbit, Io experiences gravitational pushes and pulls from Jupiter and other moons. When Io is closest to the giant planet, it is stretched by more than... And finally, an energy source, like the sun, to power the chemical reactions that make life possible. Scientists were once convinced that all three ingredients could only be found, if at all, on planets that are at just the right distance from the sun. Too close, and it's too hot. Any further away than Mars, and it's too cold. But now, missions to the outer solar system are calling this assumption into question. This is Jupiter, as seen by the space probe Voyager 1, launched decades ago to explore the outer solar system. 500 million miles from the sun, it seems unlikely that life could exist out here in such extreme cold. Voyager approaches Io, one of Jupiter's more than 60 moons, orbiting in the shadow of the gas giant. Io should be a frozen, icy, barren world. But Voyager spots something completely unexpected. These actual images of Io's surface reveal hundreds of giant, active volcanoes. Later probes expose vast lakes of molten lava. On Earth, volcanic activity is driven by heat in the interior. But Io is so small that it should have cooled down billions of years ago. There must be another source of energy inside the moon.
The discovery of active volcanism on Io was one of the greatest discoveries of planetary science.
By observing Earth's volcanoes and studying the huge amount of data gathered from Io, Ashley Davies pictures what walking on Io's surface would be like.
Walking across the surface of Io, it's a very, very hostile environment. It's either very, very cold, or it's very, very hot where there's volcanic activity taking place. And of course, there's no atmosphere. There'd be a bounce in your step because the gravity of Io is about the same on the moon, 1/6 of the Earth. You could feel the crunch underfoot as you head from one volcano to another across these vast plains. Well, here we are in the middle of a vast lava flow field. It's dark.